Good morning, students. Now we will continue the functions. The last period. So we explained types of functions, function definition, domain, range, codomain, constant function, identity function, modulus, signum, greatest integer, logarithm function, even exponential function, signum, so many types of. Now they're all PUC first year syllabus only. Today we start PUC 2 portion. Okay, so it is types of functions. Types of functions. The first one, one function. One function means, suppose it is A set, this is B set, this is F, A to B. What is the function? The function F from A to B is said to be one function. Different element of set A have different images. It is called one function. For example, 1, 2, 3, 4, A, B, C, D, E. So, different element of set A have different images in set B. So this is called one function. Even D is not no problem. Different element of set A have different images. So this is called one function. The function F from A to B is said to be one function. Is said to be one function. If different elements of set A, have different images in B. The function f from A to B, always even 100 times function, that this is the compulsory only. Without this you are writing no definition, define one function. Then some students are writing define one function if different elements of set A have different images in set B, is called one. It is not correct, this sentence. Okay? You start the function f from A to B is said to be one function if different elements of set A have different images in set B. Different elements of set A, different elements of codomain, different elements of domain have different images in codomain. But I am not taking domain, it better understood in A, that previous class I explained the set A is called domain, the set B is called codomain. So this is a domain that is called domain. That is, f from A to B is one, or even sometimes it is called injective. F from A to B is one, or what is one more name is called injective function. Injective function. For every x comma y belongs to set A, f of x equal to f of y, it implies x equal to y. The function f from a to b is 1, 1, or it is called an injective function. For every x comma y belongs to a, f of x equal to f of y, we have to prove x equal to y. Even not only x comma y, even x1 comma x2, f of x1 equal to f of x2. So x1 equal to x2. Wherever you got x1 equal to x2, the function f is called 1, 1. Okay? So even any two different domains of setting. Okay? Not only x comma y, even some textbook it is x1 comma x2 is given. Even you take y1 comma y2, but these two not codomain. These two are domain only. You have to select two different domains. So you take f of x equal to f of y. You have to prove x equal to y. So take f of x is f of y and x equal to y. You have to prove the function f is 1, 1. Okay, clear? Repeating once again. The function f from a to b is said to be 1, 1 function, or it is called injective function. Injective function if a different elements of set A have different images in set B. That is, f from a to b is 1, 1, or injective function. For every x comma y belongs to a, f of x equal to f of y. It implies x equal to 1. So this is the 1, 1 function. What is the 1, 1 function? Another name is called injective, or simply injectivity. What is injectivity? So for example, this is the set A, this is the set B, this is the F, this is A, this is the B. 1, 2, 3, 4, 5, A, B, C, D. Okay. Now this is my question is, it is 1, 1 or not? Yes. Before 1, 1, you have seen that whether it is function or not. So if it is not a function, it is not a 1, 1. It must be a function. So this is the function because our associated unit. So these are different elements of set A have different images in set B. This is f is what? 1, 1. F is 1, 1 because different element of set A. Even one more I am taking set F. This is also called 1, 1 function. Okay? Because our definition is elements, different elements of set A have different images. No problem. Even F is no image. That okay. So this is called 1, 1 function. Example number 2. F of, suppose f from R to R defined by f of x equal to x. The previous class I explained this is called what type of function this is? This is called identity function. What is called? Identity function. F of x is x. So this identity function, so this is always 1, 1 function. You take any different, not repeated. And 1, 1, 2, 2, 3, 3. So different elements have different images. This is called 1, 1. Good example. Give an example of 1, 1 function. The function f from R to R defined by f of x is x. So this is called 1, 1 function. Another example, f from R to R defined by f of x equal to ax plus b. So ax plus b, this is called linear function. What is called? Linear function. What is the linear? Degree of x is 1. So linear function f from R to R. Be carefully. The mapping also is very, very important. The mapping f from R to R, the function is linear, always 1, 1. Be carefully. Someone since say linear means linear mapping R to R, not n to n. Be careful. N to n is n to n okay, it's okay. Some not. Yeah, f from R to R, f of x linear, always 1, 1 function. Okay. So this is also linear only. B is not there. So these are good examples I give. Okay. So suppose if you want not 1, 1 function, not one function. Okay. For example, another example, f from R to R defined by f of x is equal to x square. Okay, this is question. Whether it is one function or not. What is one function? You know, different elements have different images. So here, usually the square quantity, negative, positive will be same. Even you take one answer, minus one, again it is one. So what is the mapping? This is f from A to B. Sorry, R to R, because mapping R to R is there. You want 1, you take 1. Minus 1, you take minus. Plus 1. So this is it is one function? No, this is not one function. It is a function, but not one function. Because different element of set A have different images in set B. So these are associated with the same element of in R, so in codomain. This is not a one function. So around 4 to 5 examples I explain. Okay. So this is f from R to R. Even power of x is even. Power of x is even means the negative positive will get same answer. Okay. Usually even x cube, you take instead of x square x cube, 100% this is 1 because different element have different images. Different will comes. 1 you take 1, 2 is take 8, 3 is take 27. So no one repeated. That is called one function. But power of x even not one function. Okay. This is the important definition. So what is the definition? First type of one function. Now let's start second one. onto function. The function f from A to B. F from A to B is said to be onto function, onto or subject. Is said to be onto or subjective function. Onto function, another name is called subjective. One function, another name is called injective. This is subjective means onto only. So the function f from A to B is said to be onto or subject. If every element of B means codomain is an image of some elements. If every element of codomain B is an image of some elements of A, this is the definition of onto. Very simple. The function f from A to B, is said to be onto or subject to function if every element of B is an image of some elements of A. All the elements of codomain must be image, premise. All the elements of no one is left. Even for example, this is 1, 2, 3, 4. A, B, C, D. My question is, it is one function? Yes. This is the function. This is a one function, but it is not onto, because onto means all the elements of codomain are premise. Even this E is not associated with the A, so this is not one. You remove this one, both 1 and onto. Both this 1, is also called onto only. Okay. For example, one more example I am explaining. 1, 2, 3, 4. A, B. You want only A only. Okay. Is it a function? Yes, it is a function. 1, This is not 1, 1. This is onto? Yes, onto. Because that A is a free image of what the set A. All the elements of, if every element of set B is an image of some elements of A. Even if you take B, one more element I am taking, this is a function, this is not onto function because B is not associated, no element, do not have free image, okay? So this is function, no 1, 1, no onto. So very important definition, define onto, sometimes it is the 2 marks question, define onto, even in problems also it will ask the definition, define onto and whether the given function is onto or not, check. Okay, so very important, repeating once again, the function f from H is said to be onto function or surjective function if every element of codomain B is an image of some elements of it. That is f from is the function f from A to B is onto or surjective, onto or surjective for every y belongs to B. I am taking one element in codomain, there exists x belongs to A such that f of x equal to y. Anybody tell what is the 1, 1 function? How to prove that 1, 1? Yes, in 1, 1 function, if you take f of x is f of y or f of x1 equal to f of x2, we have to prove x1 equal to x2. But onto f of x is y. Y belongs to B, there exists x belongs to A. You have to substitute y value, there exists x also belongs to A. Okay, there exists a function such that f of x is y. But in onto function, you have to calculate x value. What you calculate? X value. You have to calculate x value, substituting y, x also. Y belongs to, suppose R to R is there. Substituting y codomain, x also belongs to domain. That is called onto. So this is the definition of onto function. Okay? So for this one, 1, 1, this is the onto. For example, this is the R, this is R, because f from R to R is defined. Okay, so 1, 2, 3, 4, A, B, C, D. This is it is one onto function? No. F is not on. F is not on. Another example, 1, 2, 3, 4, 5, A, B, C, D, E. Is it a function? Yes, function. Is it 1, 1? No, it is not 1, 1. Why? Because 1 and 2 are associated with the same elements of codomain. This is not. I want a different element are different. Is it onto? Yes, because all the elements are. Suppose E I am taking E. Is it is onto? No, because E is not free image. Okay. So this is not onto. Now it is called what? F is onto. F is onto. F is onto. This is not onto. That is onto example. So another example, main question, f from R to R is defined f of x is x bar. Is it is onto or not? Definitely this function is onto, but not 1, 1, because a square quantity, both positive and negative will get same answer. Now it is 100% onto function because you take f from R to R 1, 2, 3, 4, 5. 1, 1, 4, 9, 16, 25. No one repeated. So even you take opposite, suppose for example 1 minus 1, I think this is onto function. Even if you take and minus 2, 4 and minus 4, now it is called onto. So f of x is x square is onto function, is a onto function. The first one is 1 1, second one is onto. Next definition, one is called inject function, onto another name is called surjective. Number three, bijection function. Bijection function. This bijection function is always both 1 1 and onto. The function f from R to R is said to be bijective if and only if the function f is 1 1 as well as onto. Otherwise, it's simply both 1 1 and onto. The function is called bijection. This is very, very important. So that the function f is bijection means we have to prove 1 1 and we have to prove onto. But this is both are satisfied. Both 1 1. Suppose 1 1 is satisfied, 1 2 is not, but it is not a bijection. Bijection, it must be both 1 1 and onto. What is the definition? The function f from R to R. Even you take A to B, the function f from A to B is said to be bijection if f is both 1 1 and so what is 1 1? For x comma y belongs to A, f of x equal to f of y. So this is, it's implying x equal to y. This is 1 1. Second one, for every y belongs to B, there exists x belongs to A, simply you write f of x is 1. This is called on. When the question is asking, one must question, define bijective function. Define bijective function, this much only. No need of writing to that word 1 1 and formula. Okay? Even you have to write this also, but it takes time. No, 1 marks question. The question is asking define bijection. The function f from A said to be bijection if f is both 1 1 and onto. But I am writing onto means it is onto for x comma y belongs to A, f of x is y, is f of x is equal to y. For every I simply directly am taking f of x is y. F of x is y is known as onto formula. F of x equal to f of y, x1 equal to f of x equal to f of y, x is y, this is called 1 1. This is called onto. Both are satisfied, the function f is bijection. Or simply, I told first function 1 1 function, second one is onto function. Even don't need bijection, both 1 1 and onto. The function f from A to B is said to be both 1 1 if it is bijection. It is called biject. Biject is nothing but both 1 1 and 1. For example, the mapping example. Okay, this is f from A to B. Even you take R to R, not problems. In definition, I am giving A to B here, R to R, real to real. Okay. So 1, 2, 3. Even you take A, no problem. A, B. 1, 2, 3, 4, 5. A, B, C, D, E. Yeah. So, is it is function? Yes. Function से शुरू करना. That's very important. Function, yes. 1, 1, yes. Because different element have different. Is it onto? No. No onto. No onto means it's not a bijection. So you remove this one. Yes. Both 1, 1 and on. Maybe then bijection function. Both elements must be same only, no different. Both the number of elements of set is equal to number of elements of set B only. Then only it is different element of both 1, 1 and on2. Both bijection function if you want. So m equal to n. M equal to n. Here 5 elements. Here also 5 elements. Even you take one extra here. So no on2. Okay, no on. Even you take extra here. I think this is, first of all, it is not a function because 6 is not associated any element of P. It is not a function. Not a function, no one, no on, no bijective. Okay? So this is both F is, what is F is 1, 1, 1, 1 and 1, 1 on 2 function. This is the one example. Suppose you want another example in general. In general, if you want, I told already f of x. So example, f from R to R defined by f of x equal to 2x plus 3. So this problem linear. I told the linear always 1, 1. The function f from R to R, this linear. You remember, my dear students, this is a linear, this is the R to R, always 1, 1 and R. It is always bijective function. I have not calculated a 1, 1 and 2, but 100% is a linear R to R is always bijective function. But this is always satisfy 1, 1 and R. No square, only I am telling you linear. Degree of x is 1. Okay. Suppose I am changing, suppose n to n. Suppose for example, that mapping is very important, my dear students. First you see the mapping, what is the mapping. So R to R is there, Z to Z is there, N to N2 is there, Q to Q is there. You see that very important. Suppose n to n, natural number. When f from n to n defined by f of x is 2x plus 3. I think maybe it is 1, 1 function, but not onto. Why is not onto? Because it is a linear f from n to n, natural number you know. Different element have different images because no one repeat. You take 1, 1, fine. Different element have different, it is a 1, 1. Mapping n to n, the function 2x plus 3 is a 1, 1 function. But I am telling this is not onto. Why is it not onto? You know the function f of x is y. What is this is called? Onto. This is called onto. 2x plus 3 equal to y. X 2x equal to y minus 3. X equal to y minus 3 by 2. So this is does not belongs to R. Why? But y is real number. But x is not natural number. Why natural number? If for example this is a set, you take y is maybe it is 9. Some elements possible, some elements are not possible. That is also called not. All are possible belongs to means it is onto only. Some are possible, some are not possible. But not possible is you have to write. So what is I am taking? So 8. This is 1, 2, 3, 4, 5. You also 1, 2, 3, 4, 5. What is the 1 minus the even that is not 1, 2. That is then 4. Okay. You take 4. I am taking 4. Y is 4. Okay. Y is 4. Y belongs to natural number. No? You are 1, 2, 3, 4, 5. Whatever it. 1, 2, 3, 4, 5. I am taking this number 4. Y natural number. Y natural number, but x equal to 4 minus 3, 1, 1 by 2 does not belong to n. But y natural, but x is not natural. So this is very important, my dear friend. This is what you got. Then y4, this answer is 1 by 2. So this is, but mapping n to n is there, but actually mapping is not real to real. But this is natural number, this is not natural number. So this is very important. R to R, it is a bijective function. N to n, only 1, 1, but not R to. Even not only n to n, z to z, z to z, z to z. This is a 1, 1 function. This is 1, 1 function. But onto is not possible because it is a fraction, rational number, does not belong to z. This type of problems you have to practice. One question, I will repeat it once again. Mapping R to R, linear 1, 1 and on to. It is a biject. Mapping n to n, linear 1, 1 but not on to. Mapping z to z, linear function 1, 1 but not on to. So these are. So 3 definitions I explained. One is 1, 1, another is on to, another is biject. Injective, subjective, bijective. So one more definition, but in textbook is not given. So we will explain two more definitions are there. That is called number 4. That is many one function. What is called many one. What is the many one function? The function f from a to b is said to be many one function. Many one function. The function f from a to b is said to be many one function. Many one function means 2 or more elements. 2 or more elements of set A, 2 or more elements of set A is the same image in B. Both are associated with same element. If for example 1, 2, 3, A, B, C, D, E. My question is, it is a function S. Is it is 1, 1? Yes, 1, 1 also is there. Is it is on 2? No, on 2. But I want many one function. Even this is not many one function. What is the many one? At least one or two or more elements. 2 or more elements of domain is same image in B. That is called, suppose for example, this is I am taking the mapping. Mine is it is on many one? Yes. But one associated with A and D, one is associated with A and D, this is called many one function. Totally. Sometimes all are possible. 1, 1 be रहता, on 2 be रहता, many one be रहता. That's no problem. But I want definition of many one. My question, I am not asking make 1, 1 on 2. No bias. But I am asking whether it is one, many one or yes. Because one goes to A, one goes to B. But 2 or this is 2 or more elements. 2 or more elements, no, this is 2 or more elements. So this is, for example, this, the previous one is only 2 is goes to be 1 minute, okay. What is the onto minimum function? 2 or more elements associated. For example, one simple example, not in A. This is the minimum function. Because two or more elements of set are associated with the same image in P. This is called minimum. So one more, it is called, this is called into function, not onto. It is called into function. Some elements of codomain do not free image. This is called into function. Okay. Now what is the minimum function? The function f from A to B is said to be minimum function. Minimum function. If 2 or more elements in A, if 2 or more elements in A is same image in for x, y belongs to set A, formula. X, okay. What is the minimum function? X not equal to y, it implies x comma y belongs to x not equal to y, but f of x equal to f of. I repeat. Sorry, I'm just now it is clear. The function f from A to B is said to be minimum function if 2 or more elements in domain is same image in P. For x comma y belongs to A, I am selecting 2 elements in set A, but both are not same, both are different only. When both are different, but both x and y are different only, but you will get answer same. So this is called minimum function. Minimum function. What is the minimum function formula? Please tell me. X comma y belongs to set A. X not equal to y, but f of x equal to f of y. This is called minimum function. To put example, one example 1, 2, 3, 4 A, B, C. Okay, you will take these. This much only I take. This is f A to B. My question, is it a function? Yes, it is a function. Is it is minimum function or not? Yes, because better you take 2 or more, no problem. Better take 3 is there, even you see right. Okay, see 1 comma 2 belongs to A. 1 not equal to 2. 1 comma 2 belongs to A. 1 not equal to 2. But f of 1 equal to f of. F of 1 equal to f of 2. but 1 not equal to, but f of 1 equal to f of, this is called many one function. What is called many one function. Another example, f from R to R defined by f of x equal to x bar. Is it is many one function? Yes, this is the many one function because why it is many one function? This is the is R, this is also R, this is F, this is R function, this also R. 1 minus, but x is 1 minus. So this is called many one function. 1 not equal to minus 1, but f of 1 equal to f of minus 1. This. Now repeating once again, my dear students. Is it a function? Yes. Is it 1? No. Is it onto? Yes. This problem, both onto and many one. Both onto and many one. Now repeating once again. Is it a function? Yes. Is it 1? No. Is onto? Yes. Is it bijective? No. Is it many one? Yes. This is the another type of function. But in textbook it is not given many one functions. This was for your practicing that you are preparing the CET multiple objective questions. That there comes there's a many one is there that time we were asking. So we are not discussing it. So even it's extra many one function. What is the many one function? Please tell me formula. X comma y belongs to domain x not equal to y, but f of x is f of. So another definition, into function. Into function. What is into? Not onto, it is called into. Not onto, it is called into. Very simple example. 1, 2, 3, 4. A, B, C, D, E. Okay. Now start initially. Function. Yes. Some students are not function, but you are not mentioning of RR. That's good task there. Up F from R. Now it is clear. When I am not taking F here, sir, it is not because you are not mentioning F or R. Now it is function. Yes. Why it is function? All are different. All are unique bases. Is it 1? Yes, 1. Is it onto? No. Not onto. It is called into. Not onto. It is called into. Repeat it once again. Function. Yes. 1. Yes. Onto. No. Onto. No. No onto means it is called into. Is it is many one function? This is not many one function. This is not many one function. Many one function means what? 2 or more element subset associated with same element. This is called many one function. So this is called into function. Very simple. Not onto. This is called into. The function f from A to B is said to be into. Is said to be into. F from A to B is said to be into function. If there exists element in set B, there is no free image in what? In. Or even some elements of codomain. Some elements of codomain do not have free base. of there exists an element in but B there is no free mix in some elements of codomain do not have free mix, or there exists an element in B there is no free image in it. So this is called into function. Into function is very simple. Not onto is called into function. So students, today I have discussed 5 types of definition. So these are all the two portion only. But the previous class I explained that first year only. But it's related is that the first year that I explained crops because they're most useful that crops, okay. But I'll explain in prop how it is using, using that crops shortcut method. So today, what are the types of functions I explained? 1, 1, onto, both 1, 1 and onto, many one function, and into function. Around 5 definitions I explained. That no. Note, suppose the onto means what? All the elements of codomain. Now repeat that different times sentence I am using. All the elements of codomain are premise. That is called onto. In onto, suppose for example, this is 1, 2, 3, 4, 5 there. This is A, B, C, D, E. Okay. Okay. Is it an onto function? This is not onto. This is called into. My question is it onto? This is not onto. Now it is okay. Onto. Yes, this is called onto. You remember the function f. Function f is onto, the function f is onto if domain, if the function f is onto codomain equal to range. Codomain of f equal to range of f. When codomain equal to range means the function f is 1 onto. Some problems I'll explain, shortcut, no need, only sentence you have to write. So codomain equal to range. Codomain is equal to range, the function f is called onto. What is onto? Please tell me what is the shortcut. If it is the function f is onto, in onto function always codomain equal to range. And what is the codomain? The setting. These are called domain. These are called codomain. What is the range? A, B, C, D. So codomain is equal to range is called onto function. It's called onto function. If for example, one good example I explained, yesterday I explained greatest integer function. But it's called greatest integer function. So greatest integer function, when you are asking question, whether it is 1 or not. This is not 1, very simple. F of 1 equal to greatest integer of 1 is 1. F of 1.2 equal to greatest integer of 1.2 is equal to 1. Okay. F of 1 equal to f of 1.2, but 1 not equal to 1.2. Both both are different only. One is answer 1.2 is also 1. This is not f is not 1. This is very simple. 1 you are proving is very simple. But how to prove the onto? How to prove the onto? Very simple. How to prove that 1 function you are taking x is 1, f of 2 is 2, f of 2.3 is 2. So I think different element have different elements not there. That not f is 1 1. We want different element have different elements. But this problem greatest integer I am telling onto you should tell directly. Why you are telling? Because what is the domain? Domain of f is what is answer? Real number. What is the range? Range equal to R. Suppose the mapping R to R I have given. This problem f from R to R. Anybody tell me what is range equal to I? Range equal to I. What is the domain? This is called domain. Domain is R. What is the range? Domain of f not equal to what? Range. Because here you got real number. Here what is integer? Range is integer, but domain is R. But R is not equal to I. This function f is not onto. 100% you will get full marks. Clear cut. Domain of f R लिखना, range of f equal to I लिखना, domain of f is not equal to range, the function f is not R. Suppose here also R, then the function f is R because domain f equal to range. This type of problems, then next class I will discuss with problems, very interesting problems. Okay? Then on to explain shortcut method. Domain of f equal to range, the function f is onto. So this is today's, I think maybe it is class number 8 only. So video number 8, and next video will start the functions problems. No boring, it's interesting. Okay, but you have to practice all the whatever I had thought that yesterday the videos functions. But today's type of functions, these are today's whatever he explained, no? That PUC 2, but he asked 100%, he asking definition, define 1 1, define R2, define biject2, define menu 1, define into function. Menu 1 function is also called what? 1 function is also called injective. R2, another name is called surjective. Okay, and continue next video. Thank you.